Welcome to The Explainer. Today, we are absolutely popping the hood on the tech that's powering pretty much everything right now. Tools like ChatGPT, right? We're going to look at the engine behind it all, large language models.
So to really wrap our heads around this, let's start with this kind of mind-blowing idea from AI researcher Andrej Karpathy. He has a knack for making this super complex stuff feel surprisingly simple. And really, at a high level, it's that straightforward. You take a model like Meta's Llama 2, and it's basically this self-contained little package. The first file, that's the parameters. We're talking billions and billions of numbers that are just all the patterns, all the knowledge it learned. It's kind of like a super compressed zip file of the internet. And the second file, it's just a tiny bit of code, maybe 500 lines or so, that's the engine that makes the whole thing go.
Okay, so what is this engine actually doing? Well, at its absolute core, an LLM is just a really, really sophisticated autocomplete. Seriously. It's been trained to do one thing and do it exceptionally well. Predict the next word. You give it the cat sat on the, and it's going to predict Matt with a super high probability. But here's the crazy part. It turns out that by forcing a model to get really good at just this one simple task, you accidentally force it to learn an incredible amount about, well, everything. So how do you actually build one of these things from scratch? Well, you can think of it like a recipe, and it really just has 3 core ingredients. So here's the recipe. First, you need an absolutely colossal amount of data. We'll get to how much in a sec. Second, you need a very specific kind of neural network design, and that's called the transformer architecture. And third, you need a really long and intensive training process to cook it all up. And when we say massive data, we are not kidding. Just to give you some perspective, the GPT-3 model was trained on a corpus of 45,000 terabytes of text. Okay, to put that into perspective, 1 gigabyte is about 178 million words. So yeah, just try to imagine what 45,000 of those looks like. It's just a mind-boggling scale. All right, let's talk about that second ingredient, the architecture. This is the real breakthrough that makes all of this possible. This is the engine part of those 2 files we mentioned earlier. And it all comes down to this phrase, attention is all you need. Now, this wasn't just some catchy title. It was the name of a groundbreaking paper from Google researchers back in 2017. And it introduced the transformer architecture, which is, and I mean this, the absolute foundation for pretty much every major LLM out there today. The T in GPT, yeah, it stands for transformer. So the secret sauce here is a mechanism called self-attention. Basically, it lets the model look at an entire sentence and figure out how important every single word is to every other word. This is how it gets context. So if you have a sentence like, the robot threw the ball away because it was broken, self-attention helps the model figure out that it almost certainly refers to the ball and not the robot. This is what gives it that deep contextual grasp of language that was missing before. Okay, but after all that initial training, what you get is something called a base model. And yeah, it's incredibly knowledgeable, but it's more like a weird internet document generator than a helpful assistant you can actually talk to. It definitely needs some refinement. You know, there's a really great analogy for this from Google Cloud. Think about training a dog. First, you teach it the basic commands, right? Sit, stay, come. That's the pre-training. But then, you do special training for a specific job, like turning it into a guide dog. That second part, that's fine-tuning. It's taking that base knowledge and shaping it for a specific task, like being a helpful chatbot. And this transformation is absolutely crucial. It takes the model from being this raw scholar that just kind of parrots back patterns from the internet and turns it into a fine-tuned assistant that can actually follow your instructions, answer your questions, and do it in a way that's useful and safe. This whole process, this fine-tuning, it's all about one key concept, alignment. So how do they actually do this alignment? Well, a key technique is called reinforcement learning from human feedback, or you'll hear the acronym a lot, RLHF. This is literally where humans get in the loop. Reviewers are shown a bunch of different answers from the model, and they rank them. You know, this one's best, this one's okay, this one's terrible. And all that feedback is used to teach the model what a good or helpful answer actually looks like to a person. Okay, so we've seen the recipe, we've seen the refinement process. So what does this all mean? How should we really think about these models, warts and all? Because at the end of the day, they're still just predicting the next word. They have some really strange flaws. First, they hallucinate, which is a nice way of saying they just confidently make stuff up. They also have these bizarre gaps in logic. There's something called the reversal curse, where a model might know that Tom Cruise's mother is Mary Lee Piper, but if you ask it who is Mary Lee Piper's son, it has no idea. It's weird.
And this brings us back around to a really powerful idea, again from Andrej Karpathy. He suggests that maybe we're thinking about these things all wrong. What if it's not just a chatbot? What if, instead, the LLM is actually the core, the kernel of a brand new kind of operating system? An OS that doesn't use clicks and menus, but uses natural language to control all the other tools we already have, our calculators, our web browsers, everything.
And that really leaves us with a huge question, doesn't it? If this technology isn't just a better chatbot, if it's a fundamentally new way to interact with computers, what does that mean? What are we all going to build on top of this new operating system?